What is going on, everyone? Welcome to the video. In today's video, I'll be showing you how to create custom functions implemented within YOLO version 4. I'll be walking you through how I created an object counter to count all the detections found within images and video ran using YOLO version 4. And you're going to see you can do it total objects, or you can count per class. So a lot of customability. I'm going to be showing you guys the code and stepping you through it. If you enjoyed the video, please smash that like button because it helps the channel grow, and subscribe to the channel if you want to stay up to date with all videos, AI, and object detection. All right, everyone. So how today's video is going to work is I'm going to first show you in action the two custom functions that I've currently implemented in this new repository. And then secondly, I'm going to be showing you line by line how I created one of these custom functions in hopes that you can begin to implement your own custom functions and see how easy it is to integrate them with YOLO version 4. So the first custom function that I'm going to show you is how to count objects, either the total objects in the image or video, or per class, and actually distinguish and count the different classes found. And then the second custom function and flag that I've added to this repository is the ability to print detailed information about each detection. So it's going to print the class, the confidence, and the bounding box coordinates. And I'm going to show you how you can even add more information if you want. So first things first, you're going to want to go ahead to my GitHub, the AI guys code, YOLOv4 custom functions. This is the repository I've created where I will be playing around and creating cool custom functions. It's very similar to my repository from my previous two videos. However, I wanted to create a repository that wasn't a forked repository and was my own repository so that people can go ahead into the issues tab right here and create issues, and they can actually create issues on what custom functions you want me to do next. So I actually urge you to create issues, as it will allow me to know what you guys want to see in future videos where I add to this repository, adding other custom functions. So to get the code for this tutorial, you're going to go ahead and click the code green button and then hit the little clipboard to copy it. And then you're going to go over to your command window or terminal, and then you're just going to go and do the old git clone and then paste it in there wherever you want to download the code to. So that's going to go ahead and download the repository. And then once it's finished, I'll jump right back into it. So once the code is finished cloning, you can just cd into the repository. So YOLOv4 custom dash functions. And now we're going to go ahead and install all the dependencies. I'm not going to go ahead and bore you guys with showing you how it's all done. I've done so in my previous videos, so I'll link it up above if you get stuck with any of the dependencies. For the sake of this video, I will be using the official pre-trained YOLOv4 weights that are able to detect over 80 classes. However, this does work, this repository, for custom trained YOLOv4 models. So if you have trained one, or you want to train one, you can check out one of my previous videos where I show you how to train it, and a separate one where I show you how to walk through running your custom model in TensorFlow. So both are available to you, and I hope you've enjoyed them. But for the sake of this one, I'm just going to go ahead and download the pre-trained weights. So click here. I already have it downloaded. So I'm just going to go ahead and copy it. And then you're going to go to wherever you cloned the code. So mine's repos, YOLOv4 custom functions is the repository. And then you're going to go into this data folder right here, data, and you're just going to go ahead and Control V to paste it in here. So once you've done that, you can now go ahead and run this save model command. What this does is it converts the Darknet style weights into a TensorFlow model that we can run. So we're just going to go ahead and paste that command in here. And while it runs, I'm just going to show you guys that you can indeed run on your custom model, and you can also run using TensorFlow Lite, so TF Lite model, if you're trying to run or create custom functions for Android or iOS or edge devices like a Raspberry Pi. And you can also use TensorRT, which is the most optimized if you have a high performance GPU. But I'm just using the regular TensorFlow, so it'll be a .pb model. The first command saves the model converts it from the Darknet style weights into a TensorFlow model weights file. So once the first command is finished, you're just going to want to scroll down to where I go over the custom functions and flags. So the first one, like I said, is the ability to actually count objects, either by total objects or per class. So you're just going to go ahead and copy this command over, copy, and then paste it in here. And the actual only difference between this is that it has the flag --count. So that is the flag that activates or enables the counting of the objects. And I'll show you how you can code and add your own flags later when I'm showing line by line the code. But yes, it's just --count. That is the flag for counting objects. And by default, you'll see that it's going to count the total objects in the image or video. So if I expand this, you can see that it prints on the screen total objects detected 3. So you saw the truck, the bicycle, and the dog, which is indeed correct. So we're going to go ahead and close that. And now I'll show you guys how to, in the code, change it to be per class. So you're going to go back to your command prompt, and I'm using VS Code, so I can use code dot to open up my VS Code. But you can open this up in every code editor you want. So this is going to go ahead and open up the code base. So where we're actually going to want to edit the line to enable it per class counting is either in detect or detect video.py, depending on whether you are trying to run it on video or images. So both of these commands can be referenced within the README up above. So if you're trying to see the video or webcam or the image commands, they're all up here. So for detect.py, we're just going to scroll down, and it is right here. So on line 100, this is where it says if the flag count is activated, run this function count objects, which I'll show you how to code. And then it's this parameter right here, by class equals false. If you set that to true and save, that will now enable per class. So run the exact same detect.py command with pointing to the dog.jpg, which is in the repository, so you will have it, and with a count flag. And now we will see that it actually detects or counts rather the detections per class instead of the total objects like it did prior. So you can see it says bicycles detected 1, dogs detected 1, and trucks detected 1. So it's counting each class and how many there are. Only one of each, so it is correct. And I didn't show this before, but it actually outputs to the terminal or command prompt the exact same as what you see written on the image. And you can disable that. So we can actually run the exact same command on video or webcam as well and add the count flag. And so depending on whether we wanted it to be per class, the count per class, or total objects, once again, there's going to be a line down here on line 121. Counted classes equals count objects. That's the function we're going to be creating, or I'll be showing you guys how to create that I've created. And then it's set to false. So right now, again, it's going to be total objects. But if we want to show per class, which I think is a little more exciting, you can set it to true. And then we can go ahead and run the command python detect video.py, point to the weights, which is /checkpoints /YOLOv4 -416 -- model YOLOv4, so that you can actually change this to YOLO version 3, and the exact same stuff. The exact same functions will all work with YOLO version 3. And then we set this to video now because we're running on detect video, and we do .data /video /test.mp4, and this is a file that you guys have as well, so you can run this exact same command. And then we add the flag output if we want to save the resulting video with the detections and counting overlaid if we want to save that. So we do. So I'm going to save that to the detections folder / and I'm going to call it results.avi. Has to be a .avi file extension because that's what it's configured to save as. And then now we just go ahead and add our -- count flag. So that is the detection to run it on video. If you wanted to run it on webcam, you would set this video parameter to 0. But we want to run it on our video, so we're going to set it back to video test.mp4. And we're going to go ahead and run this, and you will see that it will count all the classes per class up in that top left corner. And then, once again, that can be removed. You don't have to print it overlaid on the actual video or image. That's something I've done just for the purpose of showing you guys that it works. And you'll see as the video outputs, it will actually show the classes up there. So you can see it's got 14, 15, 16. It's counting the people as they come in and out of the screen. It's got a potted plant, bicycles detected, people walking their bikes. So as you can see, the counting objects works for video as well, which is pretty darn sweet. So when the video or image detections finishes, I just want to point out that your detections or results video gets saved to this detections folder. So right here, every image that you point to will get saved right here. And then if you add that output flag that I showed you, the resulting video will be outputted to here as well. So just to point that out. So now on to the second custom function that I've added. We just showed you the counting objects, but now I'll show you the ability to print detailed information about each detection. And once again, this will work on both the image and video. So all you have to actually do is run that exact same command that I just showed you, either the detect.py or detectvideo.py, whether you're doing it on images or video. I'm going to do it on an image, so I'm back on that dog.jpg, and all you have to do for this one, the flag to enable detailed output is --info, and you could, if you wanted to, add this on top of the command, the flag --count, so you could do both flags if you wanted to. So I'll just go ahead and, so once the command runs, you'll see this is what it outputs: object found, the class, confidence, so how confident it is that it found that object, and then it actually gives you the outputted bounding box coordinates in the format of the bottom left corner coordinate, so x-min and y-min, and then the top right coordinate of the bounding box, which is x-max, y-max. So these are the outputs right here of the coordinates relative to that image. So as you can see, the second custom function, just adding the flag for the detailed output, it's quite simple, not much to show. So let's dive into the code of how you can create your own custom function and where to add the code. So now I'm going to step through the code that I created for the custom function line by line and show you guys where to implement your own custom functions and how to do so. So I'm going to show you guys in detect.py, but it's the exact same for detectvideo.py. So what I've gone ahead and done is the way detect.py works is first up here you have all of your flags, and so this is how you define flags, and they can be a list, string, float, boolean. So you're going to see that what I've done for count is I've created a flag that is boolean, so it's either true or false, and it's set default to false, and then a little description. So the way it works is the name of the flag, defaulted value, and then the little description. So we have this count flag, and it's set to false. So detect.py, the way it works is it loads in all of your configurations, like your number of classes, etc. Loads in the model that you've saved. So if it's TF Lite, it will load in a TF Lite model. Otherwise, it does regular TensorFlow. And then it goes through, loops through each image. Whereas if this was a video, it would loop through each frame of the video. It does a little bit of reading in the image and resizing it for the model. And then it runs the model either on the TF Lite or for YOLOv3 or YOLOv4. There's a bunch of flags for if-else statements, depending on what flags you have set. So if you're running the regular TensorFlow, it does down to this else right here, and this is what happens. And then you run non-max suppression on the detections to get the best overall detections that can be found. So right here is some key variables in the file. So the bounding boxes, here are all the bounding boxes, the scores, the classes, and then how many valid detections there are. So the number of total detections. So if you're ever trying to run anything, I recommend just writing a print statement and just printing these boxes or scores. So you can just print all of these and see what they look like in order to properly get the handle of what you're going to be working with. So I've created a function to format the bounding boxes because originally they come out of this detector in kind of a normalized version. So normalized means it's a ratio so that you can scale it independent of what the image size is. And it came back in ymin, xmin, ymax, xmax. So I did a function here that you can find in the utils.py script, which is in the core folder, utils.py. And you can see that I've created this little function, format bounding boxes, just takes in the bounding boxes and outputs them and returns them into xmin, ymin, xmax, ymax relative to the image size. So now you can have bounding boxes if you're using a function that needs them in the proper format. And then there's this prediction B box, which is used to store all of the relevant information on the detections into one variable. So it has bounding boxes, the scores, classes, and the number of detections stored in it, so that you can pass just one variable into functions and then expand them within the function back out into their individual states. And then, so this is where I've created my custom function. So the way it works is it's just if the flags.count is set. So this saying if flags.count is set to true, then run the following code, and it just runs counted classes and calls the function that I've created, which I'll show you guys in a sec, and the two parameters, and then loops through the dictionary that is returned and prints a key value format. Number of blank being the key is the class name, so number of persons or dogs, and then the value, which is the count, how many they found. And then it goes ahead and actually draws the count on the image over itself. It overlays it. So I'll show you guys what that looks like. And then this is just the normal writing the detections to the folder. So that's kind of how it works. The big value that you'll want to, or variable you'll want to use in your custom functions is just this pred_b box. And you'll see I passed it in to my count objects function. So where I'm going to be having all my custom functions stored is in the core folder. I've created a functions.py script. This is where I'm going to be creating all of my custom functions, just kind of clean, easy space to work from. You could also put them in utils.py if you want, but I'm running them out of functions.py. So this is where you'll find the code for count objects. So I'll just step you guys through the function itself. So we've got defined our count objects function. It takes in two parameters. The first one being the data, which is that prediction_b box that I showed you. And then the second one is by class. This is just a Boolean value set to true or false, and it's defaulted to false right now. So by default, it will just do total objects counted. But if you want them to be per class, you would just pass in true as the second parameter. So right off the bat, what I said is it expands those what's in prediction_b box, the data, back into its respective individual fields. So boxes, scores, classes, and number of objects detected, so that we can work with them. And then I go ahead and I simply create a dictionary, because dictionary to me seemed like the easiest way to create a counter, because you can have the key to the dictionary be the class name, like person, dog, etc. And then the value that is also stored relative to that key be the actual count of how many of that object has been detected. So I've created it in a dictionary. If you see an easier way, by all means, you can change it. And then now we run into the code where if you've set that by class Boolean to true, it will run this code. Otherwise, it will just output total objects and add it to the dictionary. So if you have set the class to true, it's going to load in the class names from the config. So that's why we've done these two imports here. It reads class names from your object.names file. So if we go into the config, you'll see that this is where it points to what's being loaded in, the config YOLO classes, and it points to where your classes are stored. So by default, it will use coco.names, but if you've set up a custom object detector, you'll want to put your custom.names here. So hopping back in to the function, we now have all of our class names like persons, dog, etc. loaded in. Before they were just indexes like 0, 1, 2, 3. And now we loop through the total number of objects detected. So that is this num object parameter or variable. It actually has how many detections there are that we have found. And then we grab the class index, so the 0, 1, 2, 3 value corresponding to person, dog, etc. Because that is what comes from the detector. It returns an integer, 0, 1, 2, 3, which is just the index. So now we're grabbing the class name by using our class index. So grabbing from the list of class names, what index 0, 1, 2, 3, its corresponding class name. And then all we do is we add to our dictionary under the class name. So for persons, it's going to add persons, and this simple little count function, it gets what the value is of that key and then just adds 1. So it just counts. As people are getting detected, it'll just keep adding 1 to the count. So it's pretty simple and not too hard of a function to understand. And then else, otherwise, it just adds to the dictionary total objects key, and the value being the total number of objects. And then just returns the dictionary to the function. So it's pretty straightforward. And I'll show you detect.video. It's pretty much the exact same. It just has the if flags.count and the exact same right here. So that's why we have this draw B box, because we've drawn on and overlaid on the image or video some text. I'll show you what we've added there. So in utils.py is where the draw B box function is. So if you're ever trying to add anything to the image or video frame, you're going to want to customize this function. So what I've gone ahead and done is I've added a new parameter called counted classes, defaulted it to none, because by default, the count flag is in detect.py or detectvideo.py. It's set to false. So we don't want always outputting on the image the number of classes, only when that counted classes flag is set to true. So by default, it's none. And then we just run a little if statement here that says if counted classes does not equal none. So if we've passed in the dictionary of our counts, then it goes ahead and does this code. So it does another for loop for key value for the class and the count. It's going through and it's going to cv2 draws the text on the image. So it puts it on the image. We format it to say, so persons detected, and then the count. And then this right here is where it's going to start the text. So that is saying 5 pixels from the X value, and then this offset value. So it's going to be in the top left corner. And what this offset value does is it starts it at 15, but then it's going to add on this height ratio so that if we have multiple classes detected, it's not just overlaying them on top of each other and not drawing all of the text in one single spot. So this is a fancy way of just making sure that they don't get drawn on top of each other, and that you can take a ratio of your height and just keep adding that ratio so that the more classes it detects, the farther down the page it'll go down the left side. So yeah, right here is the little snippet that I've added to draw on, and this parameter right here is color. So if you want to change it not to be green, I've just set it to RGB color code for green. It's 02550. This is the thickness of the text, so I've just added to 2, so it's a little bolded. And then this value right here where it's set to 1 is just a multiplier of the actual font size. So you could if you put it to 2, 3, 4, the font would be a lot bigger. So I hope that kind of clears up how I drew onto the image, the count in that top left corner. And this is also where you can find the actual info flag, the detailed info. I've added it to this function as well. So if you're wanting to play around and customize what the flag for detailed, the info flag will output to the console or terminal, you can do it here as well. So that's pretty much it, guys. I hope you enjoyed the video. Please let me know in the description below what custom functions you want me to work on next. I'll be working on cropping images and as well as using TensorRT to extract text from detections. So let me know down below what you want to see in future videos. And as always, smash that like button and subscribe to the channel if you haven't already. Thanks. Have a good day.